I'm Holden, and this is my stuffed animal, Boo. And I'm very happy that Boo has a name tag this year so that we don't forget her name. So my name is Holden. My preferred pronouns are she or her. It's tattooed on my wrist in case you forget. And I'm a principal engineer at IBM's Spark Technology Center in San Francisco, where I work on Spark. And I became a committer this year, so I'm really happy about that. It makes my life a lot easier. And I've worked on a bunch of other similar stuff at a bunch of other companies. I'm a co-author of a few Spark books, one of which I get much better royalties on, so I'll try and get you all to buy the one that I get more money from. I'm also on Twitter, and the slides from today's talk will end up on SlideShare as soon as I'm back home for at least 72 hours, which will probably happen in a few weeks. And if you want to find the code, you can find it on GitHub, and I've got some other Spark videos as well. And so this slide I added after the American election because the American election, I don't know if it made all of you sad, but it made me kind of sad. And so I'm trans, I'm queer, I'm Canadian. I live in America on a work visa. One of the work visas they're currently talking about reforming, which is exciting. And I consider myself a part of the leather community. And this is just to say, like, if you don't know other people like me, like, we're normal people. We write the same shitty Scala code that you all write. I get serialization exceptions in my Spark jobs too. There's no magic, right? We're not stealing your jobs with our secret Canadian powers or anything like this. We're normal folk. And maybe don't listen to what television tells you about people like me. My employer is IBM. I really appreciate them. They pay me to work on open source software, which I think is really great. And they also pay me to come and give these talks, so it's very nice. Does anyone work at a bank or anything like that? Oh, wow, okay, actually a lot of people. Please keep renewing your IBM support contracts, and if you're debating whether or not you want to buy a third mainframe, today is the day to buy another mainframe, and make sure to tell the salesperson that Holden sent you. More seriously, I really appreciate that our business is largely mainframe-based, but we're doing a lot of work in the big data space, and I think it's pretty exciting. And I'm sure we have other products that I just never bothered to learn what the hell they were. So please buy those too. So I'm hoping you're all nice people. I'm assuming since this is a Scala conference, there's sort of a baseline Scala knowledge, so the examples will be in Scala instead of Python. How many people are completely 100% new to Apache Spark? Okay, cool. That is a lot of people, and that's awesome. Hopefully this talk doesn't scare you away from Apache Spark, but we are going to talk about Spark Datasets, and one of the things that I like to do is talk about the parts of Spark that don't work so well. And I think it's important while you're listening to these parts that I'm going to talk about that don't work so well, you remember that the other systems likely have similar things going on, they just maybe don't bother talking about them quite as much. So what is Spark? I mean, presumably you have some understanding, you bothered to come to a talk about it. Maybe you just came to see Boo, which is fine. So it's a general purpose distributed system. It has a really nice API, and it has a Python API as well. And I realize this is a Scala conference, so you're maybe not super excited about this, but I think the Python API is a great way of giving someone sort of just a taste of functional programming. And then we can hook them and convince them to become Scala developers. I don't normally say this at the Python conferences. It doesn't go over as well. But I think Spark is actually a really good gateway drug for getting organizations using functional programming and Scala. Because Spark itself, it's built in Scala, and it also really depends on a functional programming API. A lot of people come to Spark because they're looking for something faster than MapReduce. That's a really low bar that Spark handily jumps over. A lot of other people come to Spark when they've got their Python code and it's not working anymore because they're running out of memory on the largest instance they can get on EC2. and so then they use Spark to distribute their problems. And there's sort of two core abstractions. We're going to talk about the newer one today. This is the Dataset API. But it's important to note that the other abstraction for distributed computing in Spark, which is called RDDs, still exists, is still going to be maintained. It's not going away, but we're just going to focus on the Dataset one today because I only have 40 minutes, not 8 hours. So we're going to explore what Spark SQL is and how this fits into data frames and datasets. We're going to talk about how this fits into the Spark ecosystem together. For the people who are already working in Spark, we're going to sort of compare the differences between data frames and datasets to the mechanisms that you're used to working in. And then we're going to wrap up with talking about sort of the limitations of datasets and the places where they're probably not really what you want. So this slide, in addition to illustrating the fact that I do not work with any designers, or actually I do, but I haven't managed to convince any of them to look at my slides, illustrates that we have this core layer of Spark, but then there's a whole bunch of different tools being built on top of this core layer of Spark. And these are all distributed as part of Spark itself. But we can see that there's SQL and data frame library, and on top of it, we've got some machine learning tools that are being built. And starting in Spark 2.0 and sort of continuing out to the future, this diagram changes a little bit, and we can see that even Spark streaming is going to start to be built on top of data frames. And even our interfaces to other languages are very much built on top of data sets and data frames. And graph frames are coming in the future, whenever they finish them. So why should we care about Spark SQL, besides it being the future, right? The future is not very useful if it doesn't give me something I didn't have before. And I think the biggest thing that Spark SQL and data frames and datasets gives us is a smart optimizer. It also gives us more efficient storage. So in regular Spark, we use Java serialization, which I'm sure you all know is super efficient. Oh, I should also turn and wink at this side of the room too. So super efficient. But it turns out that you can actually, if you know what the data is you're doing, do better than the Java serializer. And so Spark SQL makes it a lot easier for Spark to do this. We also introduce a lot of sort of simple things. We have a much better API for doing machine learning on datasets. The old API for doing machine learning, I'm not saying it's bad because I worked on it, but you know, we certainly learned a lot in the process of making it, namely that most of the time we spend doing machine learning is doing data prep, and we didn't have any tools for doing data prep, so it was kind of useless. It turns out that people actually want to do multiple kinds of aggregations at the same time on their data, and so we make that a lot easier too in the Dataset API. One of the things which I think is really awesome about datasets is it makes it a lot easier to work with people from different backgrounds. So I really love functional programming, right? Like I'm a functional programming nerd. I like writing lambdas pretty much everywhere. But I have to work with other people, or I shouldn't say have to, I get to work with other people. And some of these people don't really like functional programming. I haven't been able to convince them that really the answer to this one SQL statement is writing a Spark job. And admittedly, it's a tough sell, right? Like, if I want everyone to learn Scala, it's going to be a while before I can work at a lot of companies. But datasets make it really easy to intermix Spark SQL and my functional programming. I don't have to spend a lot of time writing like Hive UDFs. I can just take these SQL statements, put them in the middle of my code, and then do some functional programming on top of it. I think they're pretty cool. Spark's earlier version of this was called data frames. Data frames were really interesting, except they weren't strongly typed. And part of the reason why I like Scala is I like types. It's the reason I'm not a scheme programmer, also because I like money. But I like languages that are strongly typed, right? And so datasets give me this templated typed functionality. Another one that I think is really important, and maybe less so for all of you, but if you work with people in other languages, like if you're working with Python developers or you're working with R developers, datasets give us the potential to do much better interaction between these people. Oh, sorry. Oh, crap, I shouldn't have said anything, damn it. Okay, sorry, I'm Canadian, so I apologize a lot, even when it makes no fucking sense. God damn it. Fuck. Okay. Right, back to software. So cross-platform libraries, it makes it easier to make cross-platform libraries. And to me, this is important because I work with Python developers, and I need to make tools that they're able to use, and that means exposing Python APIs. And doing this in Spark beforehand meant figuring out how to parse pickled data in the JVM, and that's not a lot of fun. You can make it work if you drink a lot, but it's really depressing. And datasets give us a unified representation of our data between these different VMs, so I don't have to drink as much. And so I think that's pretty awesome. I mean, you still can drink. So I've told you that performance is better, but like, you might not believe me. I don't blame you. So allow me to show you a benchmark. And we all know that vendor benchmarks never lie. And the grand tradition of vendor benchmarks, this probably doesn't lie, because I'm comparing my own system with itself. But if you don't believe me, it's okay. You can go to my GitHub and you can rerun this really simple benchmark. But we can see that working on RDDs can be much slower. And so if you've ever listened to one of my talks before, you've probably heard that group by key is the devil. If you haven't, group by key is the devil. And we can see that indeed group by key takes a very long time on Spark RDDs. And if you're new to Spark, that's going to be confusing, and we'll just sort of gloss over that part. But if reduce by key is a very reasonable thing to do in Spark, but even if we replace reduce by key, which is the reasonable thing to do in Spark RDDs, with a data frame, we can see the performance gets much better. And not even only at the first iteration, if we're doing an iterative algorithm, it will continue to perform better. So how is it so fast? The main thing is that the optimizer has more information about what's going on. Even though RDDs are strongly typed, Spark doesn't have a good understanding of what the schema of your data is, because to Spark, it's just an arbitrary Java class. It doesn't know what the encoder is in RDDs. But with datasets and data frames, it's a case class, and it doesn't have to be a case class, but it's simpler if we think of it as a case class, and Spark can go ahead and do a bunch of reflection magic and figure out what your data is internally and do a much better representation of this. The serialization is faster, and the really important part is some operations can be performed directly on the serialized data. And this is really important in Spark and distributed computing, where we have a lot of shuffles and stuff like this. And so it's very useful that we can do the shuffle on the serialized data. We don't have to deserialize it. If you're from a Hadoop background, you can think of it as it implements the Hadoop sortable interface. So how much more space efficient? I did this with genuine, not big data, but I ran it on my laptop, which was named Panda at the time. And we can see that inside of some random data set that I picked up, the representation in memory for data sets was 7 megs, and the same representation with RDDs was about 33 megs. And if you replace that M with a T, this starts to make a big difference. If it's just an M, if you're just dealing with megabytes of data, like, don't worry. Still use Spark, even though you don't need it, because then I get paid. But like, you know, it's going to be better. Okay, so hopefully I've convinced you that it's worth hanging around for the second part of the talk, where I tell you how to work with data sets. If you're not, and you're just like, whatever, that's okay. There's like a door over there, and it's open. I won't even notice. I won't say sorry. So getting started. So core Spark has this thing called the Spark context. And our Spark context, we can think of it as the window to the world of Spark, right? And we can go through this window. I wouldn't say sorry. Okay, we can go through this window, and we can load data. We can do all sorts of cool things. Spark Streaming has this thing called the streaming context, and we can do the same thing for streaming data. For Spark SQL, which is what datasets and data frames are, it's called the SQL context if you're hanging out prior to Spark 2.0. Otherwise, it's called the Spark session in 2.0 and beyond. How many people are using Spark 2.0 or higher? Yay! Everyone else should upgrade. There are a lot of bugs. Please don't upgrade to 2.0. Upgrade to like 2.0.1. Sorry. Okay. Sorry? If the what? Oh, okay. Do you have a JIRA number for that? We'll chat afterwards. Okay. Yeah, so Spark SQL has data types. Not super surprising. But the thing that we have to give up when we go to Spark SQL in the dataset land is I can't have arbitrary Java objects. I can't serialize my random number generator. And that's, honestly, you probably shouldn't have had an RDD of random number generators. That was kind of crazy. Most common basic types already have built-in encoders, and it's going to work for you. If you find errors about encoders, most likely you forgot to import some implicit conversions, everyone's best friends. If you did import your implicit conversions and it's still not supported, you can make a custom encoder. It is more work than just adding extend serialize. So we're going to start with loading some data. There's a few different ways we can do this. If you really like writing SQL expressions, you can just write a SQL expression against your database and go ahead and do this. Otherwise, you can use the new Spark Data Source API, and I think it's much better than writing manual SQL expressions, and we can point this at like Parquet tables or really pretty much any data source. And then we can write some programmatic queries against our data sets, and we can apply some functional transformations to them. So loading the data is pretty simple. We call SQL context.read or Spark session.read if you're in Spark 2.0. You can specify some parameters. Normally, the ones that you're probably going to care about are called infer schema and header. And then you specify the format, and you just load it. So here is loading some JSON data. Does anyone work with JSON data? OK. So keep your hands up if you knew the schema of your JSON data when you started working with it. 2 people, 3 people? OK, like 5% of the people. So one of the really nice things about Spark is that when I do this part right here, obviously Spark doesn't know what the schema is yet, but Spark will go out and infer the schema for me. And then I can get the schema information. And sometimes I use this on small data because having schema information has saved my life more times than it cares to count. Clients always tell me things are not null. Clients mean very well. They're almost always wrong. But OK, yeah, so we can also, besides JSON, there's a whole host of different formats that are supported. And because vendors are vendors, there's also a whole bunch of other formats that are supported from vendors. And if your particular format isn't supported, bug your vendor today. Or bug me, and we'll see what we can do. So here's some sample JSON data. It's about pandas because I'm obsessed with pandas. And it's a panda that lives in the mission, which is a little bit sketchy because, to the best of my knowledge, we don't have a zoo there. And it's happy, so that's pretty good, right? Like, that's the thing I care about. So I can call print schema on my JSON data that I've loaded. And then I can see my schema. And it tells me, OK, these are my fields. That's not very impressive because it's only one record, but it could be terabytes of records with like varying fields, and this would still work, and that becomes at least marginally impressive to me. But now that I know what the schema is, I can specify a case class, and then I can actually just do some really nice functional programming on top of this, right? So I've got some raw pandas. I've got some information about where the pandas live. Lovely. And then I can apply some types. And so now I've got this nice strongly typed thing. Now, admittedly, like this conversion is essentially a cast, right? We're asking Spark, like, this is what I think my data is. And if we're wrong, Spark will yell at us at this point, which is very useful, as opposed to 6 hours later, when my job has finished because I was missing one field. God damn it. So I love types, yes. We could, if we wanted to, take our data set and convert it into an RDD. Don't. We can also take our RDDs and convert them into data sets. That's much more reasonable. You convert a data set into an RDD when things have gone very wrong. Please file a JIRA, and your code's not working, right? And you need to go back to the old one. But here, if we've got some RDDs from a legacy data source, I can just turn them into a data set and do my fancy stuff on top of them. And now we can make relational transformations. And these are the things which aren't really cool, or at least they don't feel really cool to me because they're not functional programming. I like doing things with, like, Lambda expressions. But Spark also has this DSL, and this DSL is really cool because Spark can understand what the hell's going on inside of the DSL. And Spark can't really understand Scala bytecode right now, so it can't figure out what we're asking it to do quite as well when we do functional programming. So there's some benefits to doing these relational transformations. So here's a simple example. Let's say, for example, I want to know where to go to vacation, and my primary criteria is that I want to go somewhere with a lot of happy pandas. I don't really care about anything else. So I've got my data frame, I select the place and the number of pandas, and then I do this filter. And this is, I mean, it's not cool, but there are some really cool things happening because we've done it in this way. So because we've got this data frame.select, rather than doing a map and extracting certain fields into a new case class or doing pattern matching, Spark can see that we only need these two fields. And if we've loaded it from a data source, which is columnar, Spark will only actually need to load those two fields from our columnar data source. And that's really awesome. And the fastest data to process is the data that I never bother reading from disk. So this is really cool because we really help the Spark optimizer out. Okay, so as a licensed big data professional, I do have to have the word count example in every one of my talks. There's a few where I didn't, but I got a pretty severely worded warning letter. So I will have word count here. So this is doing word count in Spark's old RDD API. And this is admittedly not good. We can see the cat is about to get very, very wet, the water. It's not going to be happy. The cat is going to claw out our eyeballs. And the reason for this is this group by key expression here. And I think group by key is the most dangerous thing in Spark because it looks safe. A lot of other things in Spark, like collect, don't look as safe, right? We know if we're going to bring all of the data back to the driver program, our driver program has to have the memory to fit that data, right? Like, things could go wrong. But group by key sounds like I'm a SQL developer, and that should be fine, right? But because we're doing functional programming here, inside of map values, Spark can't see that we have this reduction that's being applied on our data. And so it's very sad. And this is going to run out of memory and fail. Alternatively, if we wanted to do this in the RDD API and allow Spark to understand what was going on, I should have gotten rid of the word group by key. Oh no, okay, pretend this example doesn't exist. We're just gonna move right along to data frames and pretend I didn't fuck up that last example. Oh well. So we can do pretty much the same thing in data frames, and our group by expression is actually safe on data frames. And this is because instead of providing an arbitrary lambda expression afterwards, we can specify the aggregation that we want Spark to do on our data. And there's a shortcut for count because the word count example is somehow standard everywhere, so we added shortcuts for it. So here we've got our data, we load it, we tokenize it, and then we count it. Now, part of the reason why this looks a little, not so nice, we've got this case statement here, is because I didn't specify the type of my input data. And this is just to illustrate the benefits of using types so that you don't have to write these ugly case statements because they're not a lot of fun. But our optimizer right now, it understands what's going on, and it can do partial aggregation. So rather than trying to shuffle the data and then aggregate all of the things that once it's done the shuffle, it can aggregate all of the data locally on each machine, and then it can do the shuffle of these partial aggregates and combine these partial aggregates, and everything will be much happier and it'll be a lot faster. We could sort of do this before with reduce by key, but it's not quite as nice. The partial aggregation with Spark data frames is a lot better. So it's more than just that, right, though? Like, maybe we're actually interested in knowing more than just word counts, right? Maybe we actually want to compute multiple aggregate statistics on our data. And maybe we don't want to do a separate action for each and every single one of those. I know, it's crazy. But the convenient thing is group by in Spark data frames now return to us this thing called a grouped data set. And we can perform multiple aggregations on this. There's a full list. There's built-in shortcuts for the really common ones. And the nice thing is the optimizer understands what we're asking it to do, and if we ask it to do a bunch of really similar things, it's going to do them very intelligently. So here we've got this like really basic example computing a single minimum. On the other hand, we can compute multiple summary statistics at the same time. And people don't seem impressed, which tells me that probably you haven't computed multiple summary statistics at the same time using reduce by key, because that shit is really fucking annoying. You end up having like all of these different things that you end up trying to keep track of, and it's a pain for no good reason to do, right? Computers are very good at generating this kind of code. And so here we can have Spark generate these fun aggregate statistics for us. Right, and the important part of actually doing nice functional programming with data sets, not the ugly stuff with these case statements. So once again, I'm interested in going to places where the pandas are happy, but it turns out some happy pandas aren't as fuzzy as other pandas, and so I'm really interested in figuring out how fuzzy all of the pandas are in the world that are happy, and I want to pretend that sad pandas don't exist. And so nice, conveniently, because I write my filter expression using Spark's DSL, Spark will just not load the sad pandas from disk, and I can pretend the sad pandas don't exist. And so that's very convenient. You could have this for much more important things, like maybe customer records. You could only load the customers who might meet some preconditions. So this is pretty basic, and yeah. No one seems excited about this. God damn it. I thought this was so cool. Okay, so how are data sets and data frames different? So Spark prior to 2.0, we're not going to worry about it too much. But in Spark 2.0, we can think of data frames as just data sets without any useful type information. They just contain arbitrary rows of data. Java users, are there any like secret Java users in the house? No one's that brave. Okay, come and talk to me afterwards if you are. It's okay. I'll keep your secret safe. But if you're a Java user, you'll note that they don't work because we were really lazy and we used a type alias. And we can do functional programming on data frames like I showed you, but it's not as cool. It doesn't feel like I'm like this functional programming wizard wearing a funny hat. It feels like I'm this person who has to write a bunch of case statements, and I don't have any funny hats. So this is nice functional style map on some data about pandas. And once again, I'm only interested in pandas who are fuzzy. I used this example once, or I tried to use this example to explain why like functional programming was like better than SQL, and people were like, Holden, I can do this in SQL super easily, and I was like, I guess I never learned SQL. But the important thing is, like, you can use this to do whatever you want, right? You can do your cool functional programming business on top of data sets, and you can still work with the people that are going to write, you know, even just raw SQL expressions. And you don't have to limit yourself to one of these two systems. There are some catches, though. Even though data sets go really fast, right? We saw that graphic, which I assure you was not faked and you can reproduce. There are some limitations. The biggest one, in my opinion, because I work on machine learning problems, is iterative algorithms on data sets tend to explode. And this is because the query optimizer for data sets doesn't know how to do common subquery expression recognition, because it's just kind of stupid looking at trees. So that's sad. And this is one of the reasons that you could sometimes go back to RDDs. And if you look inside of Spark, for machine learning, what happens is we do all of the selects and kind of stuff like that that makes sense to do on data frames. And then for the iterative part of the machine learning algorithm where we're computing the weights and our cost function for each of these iterations, we do that on top of RDDs. And then we go back to data sets afterwards so that we can continue to enjoy this really nice optimizer. The other one, which should come as no surprise to people who are used to working in Spark, is we have a bunch of more magic knobs that we have to tune around until our jobs actually work well, and no one bothered writing down what good values are for those magic knobs. But it's okay, you can just play with those magic knobs until your Spark job runs and tell yourself you're a wizard. So there are some downsides to writing our really awesome functional programming code as well. The main thing is using this DSL that Spark has, Spark can understand what the hell's going on, right? It can understand what our select expression is. It knows that we only want these 3 fields. It's just going to limit it to those fields. But if we have an arbitrary lambda expression, and inside of that we're just pattern matching on it and pulling out 3 fields, Spark doesn't understand the JVM bytecode yet. And so the optimizer won't be able to take advantage of this information. So this comes down to a trade-off. It is still faster than RDD transformations quite often, because even though Spark's optimizer doesn't have a good understanding of this particular step of the process, it has understanding of what's happening before and after. It also has a better understanding of what the data types are than in RDDs, and because it has a better understanding of the data types, it's much more efficient storage-wise. And that's a really big deal because that also affects how much data has to go across the network. So it's still often better than RDD transformations, but it's not often quite as good as doing things in the DSL, which I don't really like working in. And I probably don't use as often as I should, but whatever. So doing the impossible. Damn it. Okay, so this is a cat wearing a garbage bag. To illustrate that it's more like doing the annoying things that are annoying to do in Spark RDDs. So one of the cool things is we can do streaming inside of Spark. Sorry. Has anyone used the old dstream API? Did you like it? He shook his head. So the dstream API is kind of like, I don't want to call it the Ford Pinto, because I don't know if you had the Ford Pinto, but you know, it works. It gets you from point A to point B, but if anything goes wrong, it explodes and you lose all your data. And structured streaming is similar, but we have the opportunity to make it better. It's built on top of the same APIs. The dstream API introduced a new class hierarchy to do streaming, so if you wanted to reuse your code, it was certainly possible, but you had to do a fair amount of work to make this happen. And so let's take a look at how this can work. So the biggest difference that you'll see if you're coming from sort of doing batch processing on datasets in Spark to streaming processing on datasets is that schema inference no longer works for many data sources. And this is just because schema inference requires like sampling your data and figuring out what the fields look like. And with streaming, I can't just like wait until my job is finished and sample these records. So I have to actually specify my schema. The other one is to tell it the difference. We call .readStream instead of .read. But then we get back this really cool streaming data set, and I can do the same kind of aggregations, right? Like this is the same aggregate that I had before, except instead, this is trying to resolve the old argument I have with my coworker of if coffee and happiness is directly related. They say no, I say I'll cut you with a knife if you take away my coffee, and we see how this goes. But this is really cool because I could have the same code for batch processing as streaming processing. And I think that's cool. There are some restrictions, of course. Everything comes with an asterisk. This one comes with the asterisk of please don't use it in production. It will get there soon, I promise. But if you use this in production and you work in healthcare, I don't want to die. So please, please don't. I mean, killing other people is also bad, not just me. But like, this is really cool, but it will sometimes explode because it's not finished. We can do machine learning with it. I think this is pretty cool, right? This is a really simple machine learning pipeline, but it very closely illustrates how to build a simple thing. And we can have all sorts of different stages inside of it. Clicky button. There we go. Okay, so in Spark, there's a few different things that we need to do machine learning tasks, but the first one is we need to make a vector of features. So here we can make a vector of features. We can specify what our label is that we're training on, and we can put these together into a pipeline. And we can train a decision tree classifier on top of this. And so this is really simple, and I think it's really cool because we can just take our data sets that we've been doing even our streaming work on. Maybe we've collected them into a table, and then we can go ahead and we can build machine learning models on top of it. I don't have to go ahead and put it into a second system, right? I don't have to install Mahout on my cluster. Not that there's anything wrong with Mahout. Those people are very nice. But this is pretty cool. Yay! It's a cat wearing a hat. The other one is windowed operations. These are definitely possible to do in Spark, and I've certainly written windowed operations on top of RDDs, but you often end up having to write a lot of code that has to think about how your data is distributed, and what happens if your data is split between two partitions. And generally, in my mind, when you have to be thinking about that, that's a sign that we've failed you. You should be able to pretend that the magic computer is not actually made up of 300 gnomes. Those 300 gnomes are all working together, and they'll give you your answer. But if you do windowed operations on RDDs, you have to be like, okay, this gnome has like 2/3 of the data, that gnome has the other third, and this gnome, crap. And then it's not a lot of fun. You spend all of your time thinking about how your data is distributed. So we can specify windows, and we can compute some averages. And so it's really easy. I can be like, I want to know, so in America, we tax capital gains differently. Oh, actually, I shouldn't say we, because I'm not a citizen. But in America, they tax capital gains differently. And maybe I'm curious how this impacts people in different age brackets. And so I can write this very easily, and I can get this windowed average of what people's capital gains are by age. And there's actual data for this if you're curious. It's very sad if you care about income inequality in America. Sorry, I didn't mean that to get so depressing. Okay, summary, why not to use data sets? It's not income inequality, although, I mean, we're probably making that worse. We can solve problems that are tricky to solve with RDDs. Sorry. It's fast. The optimizer is a lot more awesome. And this is just inherent with, it has more information than we can give it in the RDD API. The other one is if you have to work with other people, and if you get to work with other people, it can save you from the hassle of having to write UDFs. Has anyone enjoyed writing a Hive UDF in their life? 0 people, right. So it can save us from having to spend a bunch of time packaging our code to make it usable for other people. We can just write things like we normally would, and other people will be able to enjoy them. And so I think that's pretty amazing. The most important slide. Second most important, because the next one has the link where you can buy it. There are a lot of books on Spark, and they cover a lot of different topics, not just data sets. I am a co-author of many of these books, but I receive the highest royalties for this book. And this is the one that you should all buy, especially those of you working at banks. I know you have expense accounts. So please buy several copies. It is the gift of the season, whatever that season may be, it is the gift for it. And the ebook is actually available today. The print version will be available, my publisher says soon. So probably in the next 2 or 3 weeks, unless customs decides to get in our way. Maybe Trump is listening to all of the things I'm saying. But please buy it today. I receive almost enough money for a cup of coffee when you buy one of these books, and I like drinking coffee. Sorry. And I have some other upcoming talks. I am obviously at Scala Days today, so I should have taken that one off. If anyone's looking for an excuse to go to San Francisco this weekend, you can come join me in San Francisco. I have a group of people that like to ride scooters together, and if you want to come join our group, we can talk as well. And there's Berlin Buzzwords, which is probably a fair amount closer, and Scala Swarm, and wait, was Scala Swarm in the past or the future? Oh God. My travel schedule is a little crazy. I'm pretty sure these conferences are in the future. If they're in the past, they were awesome. And the ones in the future will definitely be awesome too. So please rate this session unless you think it was crap, in which case, please don't rate this session. You can come and complain to me and Boo in person, and we'll try and make it better. And yeah, okay. Yeah, there we go. This is the one I wanted. This is the cat. So thank you so much for listening. You laughed at many of, but not all of, my jokes. So you've been a very nice audience. Does anyone have questions for me? Okay. Questions? I mean, they can also be for Boo.
As a newbie question, the ML library, is it possible to, I'm over here.
Yes, no, I'm happy. Yes.
So the ML library, is it possible to export all the models you can generate? I heard it was not, so.
No. So many of the models can be exported, but not all of them. The export right now inside of Spark ML is the unholy union of JSON and Parquet. I don't know why we stuck those two formats together, but we did. And so it's understandable by approximately 0 other systems. So you can save your model and load it back into Spark. PMML export is something that I've been working on, but I kind of got lazy. So maybe bug me some more and we'll add more PMML export.
Hi. I was wondering regarding triggers and watermarking in streaming. And it's usually the most difficult part in streaming, so if you can recap on it.
So Spark structured streaming is still very basic at this point. The triggering is limited to time-based, which is unfortunate.
Processing time or?
Yeah, so what happens is on the driver program, it kicks off a separate thread for each stream, and at a specific interval, it'll schedule the next microbatch job to process the stream. It doesn't currently allow specifying like a window size based on the number of records, which is what a lot of people want, but is not currently supported. Hopefully we'll get there soon. Watermarking. Yeah, I'm sorry. That is another thing which is soon. But there's some debate as to how to do this properly with the current execution model. And they're actually in the middle of kind of changing a lot of the pieces, so we'll see how long it takes. If you want to come to San Francisco, TD will be giving a talk there, I'm pretty sure, which may answer some of your questions. Alternatively, I think there's a live stream from San Francisco you might want to check out. I think I'm out of time, right? And there's no more questions anyway. So thank you all for coming, and I hope to see you around.